Hello all, welcome to part 3 of the Windows Assembly Language for Hackers Primer series. In this video, we will look at doing Win32 assembly using the MASM32 package. So in the previous video, you noticed that because MASM does not ship with a runtime library of itself, it is very difficult to figure out each and every API which Windows has, figure out the constants, and then feed those values individually into the program. Now this becomes more and more difficult as your program grows larger and larger, and you end up referencing a lot of APIs from the Windows packages. This is where MASM32 comes to our rescue. MASM32 is a package which actually includes MASM 6.1 and link.exe internally. Now the beauty about MASM32 is that it provides the runtime library, the include files, macros, even a simple to use IDE to make programming much more faster and scalable in Windows 32-bit assembly. Also, MASM32 is maintained by Hutch, who's probably done an incredible job in ensuring that the libraries and include files are as latest as possible. So for the rest of this assembly primer, we will go ahead and use MASM. So before we begin, it is important to create a lab environment. Now it might totally be left to you what you would like to do, but I would recommend probably dedicating a virtual machine for this series, and I probably am going to use an XP Service Pack 3 within which I'll run most of my demos. You can download MASM32 from this URL, masm32.com, and you can install it. It's pretty straightforward to install it. And as and when required, we will download other utilities and programs. So once you install MASM, you would actually come and there will be a directory with a lot of these files, etc. We'll visit some of these in a moment. There is no code directory. I've created a code directory in which we will put all our sample programs, which we will run during these exercises. So how would you leverage the MASM32 library? Now the help files for MASM32 are located in MASM32 help. The library help file is located in MASM lib. So if we go to the help directory and we double click on the MASM lib file, you would actually find all the different library functions which MASM allows us. Right? Let's go back here. Now this contains the documentation, and if you want to go ahead and use MASM32 library in your projects, you have to go ahead and first add the include file, and then also go ahead and include the library in the project. These can be done by using the include and include lib directive of MASM. So without further ado, we'll go through 3 simple demos in which we will recreate the Hello World program and probably something a little bit more interesting using MASM32. So the first is to recreate the Hello World program which will run within a console. Now I already created the program just to save a bit of time in a file called hello masm32.asm. Let me go ahead and open this file up using Vim. Now most of the invocation remains the same. .386 is to tell MASM what instruction set to use. Model flat, this is more of the memory model. STD call is the way in which you would actually want to invoke different functions. Option case map basically says that the labels are case sensitive. .data contains all the initialized data. In this case, we've just initialized a simple string called demo, which contains the value demo. And then we have the start routine under the code segment. Now in this, what we do is we will go ahead and use a new directive called invoke. Now, invoke, what it does is it will go ahead and call the function along with the rest of the arguments. So you may be familiar with exit process, something you may have remembered from your old C days, and this is akin to the exit function. And if you remember, we pass in an integer value, typically 0 most of the times, and here this has been called using invoke exit process 0, right? However, this program is still not free from error. We'll come to that a bit later. Also note that you have the invoke std out, where you pass on the address of demo. Now std out is a library specific to MASM32. So if we go back to the help file, you will notice that std out basically will display a 0 terminated string. Now, one of the important things which we had mentioned is that we need to go ahead and add the include files and libraries. So, of course, you need MASM. Now, along with this, for Windows, MASM has a special include file where all the function prototypes, etc. are defined, called windows.inc. Along with that, we are calling the exit process API. So we need to figure out in which file exit process exists. So you can go here, just quickly type in exit process. This would give us the MSDN page, and if you remember from the previous video, it exists in kernel32.lib. So what we do is we add another include. In this case it's going to be kernel32.inc, and we need to go ahead and add the kernel32 library. So this would end up being kernel32.lib. So if you notice, these are some of the key differences in comparison to what we had created previously. Okay, so everything seems okay. Should we go ahead and compile it? Let's save it. Let's go to the same directory, and the name of the file is hello masm32.asm. It's almost rhyming. So let's just go ahead and first compile it. Right, and here goes. So if you notice, there seems to be a error here, right? That's typically because ideally should go ahead and put this on top. Awesome. So the assembly has happened. Now let's go ahead and link it using our favorite linker. For that matter, the only choice we have. You also have T-Link, by the way. You have TASM and T-Link or Borland, but I guess they are pretty much obsolete right now. Anyway, the subsystem for which we want to compile this is the console, and the library we need to mention here is kernel32.lib. Then we have hello masm.obj, which is the object file. Perfect. Now let's go ahead and run hello masm32, and as expected we have the demo word printed on the screen. So here is a simple example in which we saved a lot of code writing, and in which we were able to call a little bit of a high level API with an assembly and do the actual printing job, right? Awesome. Now let's move on to the next example. So the next demo we are going to look at is replication of the message box A hello world demo, but using the MASM32 package. So this is in hello windows.asm. Here we go. You can open it up in Vim. In this, the include files, etc. have already been added. Now you'll notice some interesting things here. Of course, hello world is defined as we had defined it previously, but we use the invoke directive to actually call the message box API, and some interesting differences here being that we are directly using the constant MB_OK, right, which has the value of 0. Previously, which we had to feed in manually, if you remember. If you go back here, MB_OK had the value 0, which is what we had actually fed in manually. So now MB_OK, etc. have already been defined in one of these include files. In this case, it should ideally be the user32.inc file, because that is the library message box resides in. So let's see if this assembly is gonna work. Let's go back. Hello windows.asm assembles perfectly. Let's go to the linking part, give it the object file. In this case, what you would notice is that we can once again go ahead and compile it as usual, and then we can actually run hello windows, right? And this is the output which we had got previously also in the last video series, but in this case we actually used MASM32 library, which made our life much more simpler. Okay, awesome. Now these two are very simple programs which we have replicated using the MASM32 package. Now let's do something a little bit more interesting. Let's do a simple calculator program which will add two numbers and subtract them. However, these two numbers need to be asked from the user. Okay, this is the demo 3 which we'll have. Okay, sorry, I think that is for the next video series. In this case, we'll create a simple program which takes user input and echoes it back to the user, right? And this is coded in reflect.asm. Here we go. So let's try and understand what are the extra things we are doing. Now, of course, in the beginning, we need to go ahead and ask the user for input, which means we would have to store the user input in some kind of a buffer. This is what we define here, user input define byte, and we take a byte array of size 255 and fill it up with zeros. So 255 dup, which is duplicate 0, what it does is it creates 255 bytes and makes all of them individually 0, right? It's kind of like a null string which we have here. Then we invoke stdin, which is a library function offered by the MASM32 library. Now let's study how it is invoked. The parameters are the buffer to receive the text input in, and then the length of the buffer. So in this case, user input is the buffer, right? We're passing on the address of that, and then the size of the buffer is 255. Well, just to be on the safe side, we give 254 as the maximum size, so that there's still a end null which is existing. After that, we go ahead and invoke stdout, and if you remember, stdout needs to be passed the address of the string which needs to be printed, which is once again user input, because that is where the user input was stored. Finally, we call exit process. So if you have a look here, using the MASM32 library, it's almost as if we are doing high-level programming, right? Life has become much more simpler. Okay, so let's go and compile this program. Sorry, assemble this program. right? Assembly works perfectly. Now let's just go and link this program. Linking works perfectly. Hit reflect, waiting for our input. Let's type in something. Hello there. It reflects back the same input to us and exits, right? Simple programs. So the whole idea beyond these demos is how we can use the MASM32 library and build assembly programs much more faster. Now I would really encourage all of you to try all these 3 programs by yourself. First, without looking at the code, which I've already supplied on the same page. And if you get stuck, look at the code and do it, right? In the next video, we will look at a lot of directives which ship with MASM, which we will use to write absolute awesome assembly code, and a couple of other interesting demonstrations. So I'd really encourage you, please do the demos. Write your own code, assemble it, link it, do the whole thing by yourself, right? As always, would request you to please leave your comments behind. That is what keeps me going. So please leave comments behind. Thank you.